aggregate impact value test. So, our aim of this practical is to find out the aggregate impact value of a given aggregate sample. For this we are referring the IS code, that is 2386 part number 4. The apparatus which is required for this test are: first one, aggregate impact value machine; second, the sieves are required, that are 12.5 mm, 10 mm and 2.36 mm. Then we required one measuring cylinder which is having an internal diameter 75 mm and depth of the cylinder is 50 mm. Then weighing balance is required, oven, and tamping rod is required, that is having a 10 mm diameter and 230 mm length. So, now we have to do the procedure. First, for this sample preparation we have to take a oven dry aggregate which is passing from 12.5 mm sieve and written on 10 mm sieve. Here we have taken two sieves, that is first one 12.5 mm sieve and second one is the 10 mm sieve, again pan. So, we have to take the aggregate which is written on 10 mm, that we have already taken, and that we have to dry, oven dry for 4 hours, that having a temperature 100 to 110 degree Celsius. Now, we are going to do the sample preparation procedure. For this practical we are taking the measuring cylinder for the sample preparation, that having a diameter, that is internal diameter having a 75 mm diameter and 50 mm depth. Then we are taking the impact value apparatus cylinder, that having a diameter 102 mm and 50 mm depth. Again we are taking the tamping rod for the tamping, that having a 10 mm diameter and 230 mm length. Then for this test we required a 2.36 mm sieves. On that we have to calculate the passing and retain weight after the test, and one weighing balance is required which having accuracy up to 0.1 gram. So, now we will do the procedure. First we have to put a small amount of aggregate, that is the 1/3 of the portion of the height of the measuring cylinder. Then after filling that aggregate layer we have to tamp each layer 25 times. Now we are filling second layer of the aggregate, and again we have to give the 25 times strokes or 25 blows to the second layer in a equal manner. We are adding a third layer, that is the final layer. Up to top we have to fill, then stroke of extra aggregate, and again we have to give the 25 blows to the top layer. So, now we have filled this measuring cylinder with the aggregate, and we have to take the weight of mold plus aggregate. Already we have taken the empty weight of mold, that is 1268 gram, and now we are taking the measuring cylinder plus aggregate weight, that is 1634.5 gram. So, we have to calculate W1. So, first what is the W1? W1 is the only weight of aggregate which is filled in a measuring cylinder. So, we have calculated the empty weight of cylinder, that is 1268 minus 1634 we have to do, and we can calculate the W1, that is the weight of aggregate. So, now we will do the exact procedure of the impact value. This is the impact testing machine. We will see one by one the component parts of this. So, this is the mold which having a 102 mm diameter and the 50 mm depth. This is the hammer which having a 13.5 to 14 kg weight handle. Then here we can count the number of blows which we are giving. So, now what we have to do, we have to transfer this aggregate sample which you have already taken, that transfer the sample in the mold, and will give the 25 strokes at a topmost layer. Then will give the 15 blows of hammers to the sample, which within the 1 second will do that, and again we have to calculate the impact load or impact value of the aggregate. Next, this free fall height is having a 380 mm plus minus 5 free fall height is there, and we are giving the 15 blows with the hammer. Now we have to release this knob and Okay, so now we have given the 15 blows to the sample at a regular interval, and we have counted the blows on the dial gauge, and now we are going to remove this mold and we will sieve on the 2.36 mm sieve, and we have to taken the weight of passing aggregate as well as the retain aggregate sample. Now this is your 2.36 mm sieve size, and we have to take this aggregate sample which is already taken, that is we have to sieve this sample from the 2.36 mm sieve, and so we have sieved this sample, and now we have to take the aggregate which is passing through 2.36 mm. Now we are taking the weight of that. So weight of this is the 65.5. So this is nothing but the weight of aggregate passing through 2.36 mm sieve after the test, that is denoted as W2, 65.5. Now we have to take the aggregate which is retained on the 2.36 mm sieve. We can use the brush to remove this aggregate. So now we have taken the weight of aggregate retained on the 2.36 mm. So that denoted as W3, and the weight of aggregate is 300.5 gram. So the difference in between two weights, that is the W1 is the total weight we have taken at the earlier stage, and W2 and W3 which are weight passing and retained on the 2.36 mm. So we have to calculate the difference of this, and why we are calculating this difference, because this difference should not be greater than 1 gram. If the difference is greater than 1 gram, then we have to repeat this test, we have to discard this test. Then as per our calculation, the difference is lesser than 1 gram. Okay, so now we have taken the CU's weight passing and retain, and we have calculated each thing. So difference that is in a weight 0 gram, and the actual aggregate impact value we have to calculate, that is W2 upon W1 into 100, and that we have calculated already, that is 17.89%. So your result of a given sample of aggregate is 17.89%, and the conclusion is if the aggregate impact value ranges between 10 to 20%. So it is considered under or called as a very strong or very tough aggregate, and that can be used for the road surface or pavement course.